Hello guys, in this session we are going to see about how to find a number whether it is odd or even. So let us take a number as n is equal to 5. Normally we find odd or even numbers like if n modulo 2 equal to 0 it will be even, else it will be odd. So instead of using this modulus operator we can also use some bitwise operators such as XOR and bitwise XOR, bitwise AND, bitwise OR, bitwise logical negation, bitwise negation, and etc. So here we are going to see two procedures. Procedure 1 deals with bitwise AND and procedure 2 deals with bitwise XOR. So let us see one by one. First, bitwise AND. So what AND operator does is, if both inputs are low means 0, or any one is low, it returns 0 as output. Else, if both are high as 1, then it is returns output as 1. So let us see how it works. Let us take a number as 5. If n ANDed with 1 equal to 0, let us put a separate bracket for this. N it is equal to 0, then it is even number, else it is an odd number. Let's check how it works. So bitwise operators deals with binary representation of digits. So binary of 5 is 1 0 1. So 1 is 0 0 1. So 5 ANDed with 1 gives first same integer and 1, same 0, any 1 is 0 0, which is not equal to 0. Hence 5 is an odd number. Let us take an input as 4. So 4's binary representation will be 1 0 0. For 1 it is 0 0 1, and 4 ANDed with 1 gives all the streams contains any 1 as 0, so 0 0 0, which is equal to 0. Hence 4 is even number. Let us take some other inputs like n is equal to 7. What is the binary representation of 7? 1 1 1. For 1 it is 0 0. So 7 AND with 1 gives same inputs, so 1, different inputs 0 0, which is not equal to 0. Hence 7 is odd number. This is how we find using bitwise operators. So step 2 deals with bitwise XOR. What is XOR? Normally it is pronounced by many people as XOR. So what does this XOR or XOR operator does? If both inputs are same, like 0 0 or 1 1, the output will be 0. Else if different, like 1 0 or 0 1, output will be like 1. So let us take a number as 5. What is the logic for this operator is that if a number XOR with 1 which is equal to n minus 1, so it is said to be as an odd number. Or let us consider like if a number XOR with 1 equals n plus 1, so next integer, so it is said to be as an even number. Let us check for both the cases, right? So considering 5 XOR with 1 gives, so 5's binary integer will be 1 0 1. So for 1 0 0 1, when 5 XOR with 1 it gives same inputs, so 0, same, 0, and hence different inputs, so it is written as, so which is the binary representation of 4. 4 is equal to n minus 1, so it is equal to n minus 1 since if it is an odd number. So 5 is an odd number, right? 5 is odd number. So let us take some other inputs like n is equal to 8. If 8 XOR with 1 gives 8's binary representation will be 1 0 0, and for 1 it will be 0 0 1. So 8 XOR with 1 gives different inputs, so 1, same inputs, so 0 0, different inputs, so 1, which is a binary representation of 9. See, 1 2 4 8, so 8 plus 1 it is 9. 9 which is equal to n plus 1. So if a number satisfies n plus 1 condition, it is an even number, right? So 8 is an even number. Let us check with some other inputs. N is equal to 3. So 3's representation will be 1 0 1, 0 1 1. For 1 it will be 0 0 1. So 3 XOR with 1 gives same inputs, so 0, different, so 1, same, so 0, which is equal to 2, which is equal to n minus 1. So if it is an XOR equal to n minus 1, then it is an odd number. Hence 3 is an odd number. This is how to find whether a given number is even number or odd number using XOR operators and bitwise AND operators. So now let us implement this in code. It can be implemented in any C, Java, any languages. So let us now see how to implement this in Java code. Let us see how to implement this in Java. So first input the packages, next scanner class, then long if n and 1 equal to 0, even number, else odd number. So let us check how it works. Give the inputs as 3, it's an odd number. So 4, it's an even number. So 2 4 5 6, it's an even number. Let's try with some big long integers. It's an even number. It's an odd number. So even when we give integer or long integers with some 2 4 6 8 10 12 14 15, we can give some big integers. This also till 2 power 8 10 power 18 integers we give, right? The time is 0.26 seconds, so less time. We can also try with bitwise XOR operator. So for that we can write two functions, Boolean functions. For if it is odd, we have discussed like if n XOR 1 equal to n minus 1. In such cases, it is an odd number, so return true, else return false. Right? Let us consider another function is even. So if n XOR with 1 equal to n minus 1, we have to return true, else return false. In even case, it should be n plus 1. So here we pass if is odd of n. So print odd number, else if is even of n, system dot printf even number. So let us check with the input. Giving the inputs 3, so odd number. 4, even number. Let us try with some inputs, bigger integer. So even number, some other integers. Odd number with some less time complexity and less memory space. So this is the logic for finding odd number using XOR, and this is logic for finding even number using XOR. So this is how we can also find odd number and even number using bitwise operators. So thank you. Let us see in the next session.